My name is KwabenaHopkins, and today I'll be going with 3.2, which is exponential functions, logarithmic functions, their derivatives, and how to apply them. My objectives for this lesson are that the student will be able to calculate the derivative of e to the x and the natural log of x. The student will be able to compute the derivatives of other logarithmic and exponential functions, and the student will be able to derive and use exponential and logarithmic models. I'll start off with exponential functions. Exponential functions center around e to the x. E is a constant. It's a mathematical constant. It's a number, 2.71828, and so on and so forth. It's like pi, really. And the reason you can't use the power rule in this is because you cannot use the power rule if the base is a constant, which e is, it's a number, and the exponent is a variable. Normally, the power rule is used for if a variable is raised to a constant, but it cannot be used in this equation. So that's why we have exponential function derivatives. The first property I'll be showing you for you to memorize and use when I give you some examples later on will be f of x equals e to the x. The derivative of this is f prime of x equals e to the x. It's the same thing. That's very easy to remember. The next property I'll be showing you is f of x equals a raised to the x. A being any number 1, 2, 3, 4, 5. F prime of x would equal to a to the x multiplied by the natural log of a. The next property I'll be showing you is f of x equals e to the g of x. G being any equation. F prime of x would equal e to the g of x multiplied by g prime of x. And the last property I'll be showing you for exponential equations would be f of x equals a to the g of x. The derivative of this would be f prime of x equals a to the g of x multiplied by g prime of x multiplied by natural log of a. I'll just move the way so you can see everything. Okay, a few examples I'll be giving you so we can apply these properties. Don't need to do this one because it's self-explanatory. F of x equals 4 to the x. We're using this one because 4 is a number, which a is symbolizing this one, and it's raised to a variable. So it's very easy. Just look at the property. So f prime of x would equal 4 to the x multiplied by natural log of a, which is the constant. So natural log of 4, and there you have your answer. Another example, f of x equals e to the 6x squared plus x. Look at your properties. Identify which one we'll be using. We'll be using this one right here, which is e to g of x. Just follow what the property states. So f prime of x would equal e to the 6x squared plus x multiplied by the derivative of 6x squared plus x, which will be 12x plus 1. And there you have your answer. You can put this in the front of e if you want, but it's not required. But this is basically what your answer is. And the final example I'll be showing you for exponential functions, f of x equals 2 to the x cubed plus 4x. Which one of the properties? Look at the properties. I'm using this one. So f prime of x, all you gotta do is follow the formula. F prime of x will equal 2 to the x cubed plus 4x multiplied by the derivative of this, which is 3x squared plus 4 multiplied by the natural log of a being 2. So multiplied by natural log of a. This is your answer. Now, of course, you can simplify it, but you don't have to. and this can be your final answer. And now I will be focusing on logarithmic equations, what properties for the derivatives, and I'll give you some examples for those as well and how to apply those derivatives. First, natural log. F of x equals natural log of x. The derivative for this would be f prime of x equals 1 over x. Very simple. Next property I'll be showing you is f of x equals natural log times g of x. The derivative of this would be f prime of x equals 1 over g of x, and that multiplied by g prime of x. So basically, g prime of x over g of x, if you want to get simpler. Another property I'll be showing you is f of x equals log base a of x. The derivative of this would be f prime of x equals 1 over x times the natural log of a. And a being the base of this function. So, and the final property I'll be showing you for logarithmic functions is f of x equals log base a to the g of x. And the derivative of this, the property for that will be f prime of x equals 1 over g of x times the natural log of a. And all of this multiplied by g prime of x. Okay. Now that I give you the properties, I'll give you some examples to apply these properties. First example I'll be giving you, f of x equals natural log of 4. All right, so we're going to look at our properties, see which one do we use. The top one right here, x is 4 in this scenario, so just look at the derivative and plug it in. So f prime of x would equal to 1 over 4. My next example I'll be giving you is f of x equals the natural log of 3x squared plus 5. All right, look at our properties, which one will we use? This one is the one we will use for this one because it's natural log to an equation, g of x. So f prime of x, we look at what it is, will equal 1 over g of x, which is 3x squared plus 5, and that multiplied by g prime of x, which is 6x. And your answer is simplified to be f prime of x equals 6x over 3x squared plus 5. All right, for next example I'll be giving you, f of x equals log based 2 of x. So look at our properties. 2 is a, because it's any number, and so we use this property. So just follow, and f prime of x would equal 1 over x multiplied by the natural log of a, and a is the base, so natural log of 2, and that's your answer for that one. And the final example I'll be showing you for the logarithmic functions and the derivatives is f of x equals log base 3 of x squared plus 2x. We'll be using this property, and all you gotta do is follow. So f prime of x would equal 1 over, can't see, I'll just go ahead and reach out there for you. F prime of x would be equal to 1 over g of x, which is x squared plus 2x, and that multiplied by the natural log of a, which is, a is 3, so natural log 3. And then all of this multiplied by g prime of x, which is 2x plus 2. 2x plus 2. Now to simplify this, just put this, multiply it by the numerator, and you have your answer as f prime of x equals 2x plus 2 over x squared plus 2x times the natural log of 3. And that's the final example for logarithmic functions and their derivatives and how to apply them. You can see, look at it. And to summarize, I'll just tell you all of the properties all over again. Not write them down, but I'll just tell them just so you can engrave them into your memory. Again, E is a constant. It's a number, so you can't really use the power. You can't use the power rule for exponential equations. So if f of x were equal to e to the x, derivative would be f prime of x would equal e to the x. Same thing. F of x equals a to the x, where a is a constant. F prime of x equals a to the x multiplied by the natural log of a. If f of x equal to e to the g of x being an equation, f prime of x be equal to e to the g of x multiplied by g prime of x. If f of x would equal a to the g of x, a being a number 1, 2, 3, 4, or whatever you want it to be, f prime of x would equal to a to the g of x multiplied by g prime of x multiplied by the natural log of a. If f of x would equal to the natural log of x, f prime of x would equal to 1 over x. If f of x equal to the natural log of g of x, f prime of x will equal to 1 over g of x multiplied by g prime of x, or g prime of x over g of x. If f of x will equal to log base a to the x, f prime of x will equal to 1 over x multiplied by natural log of a. And finally, if f of x will equal to log base a to the g of x, f prime of x will be equal to 1 over g of x multiplied by the natural log of a, and all of that multiplied by g prime of x. Thank you. This is 3.2, and that is exponential logarithmic functions and their derivatives and how to apply them.